Hey guys! Before we dive deep into the actual primitive data types in Java, I want to quickly explain something important, something that will help you understand the difference between them. Here we have Bob asking the machine, "Hi, what's your name?" And the computer replies, "I don't understand." This is because the language of machines is different than the language of humans. They only speak zeros and ones. The language itself is called binary. Everything we type, whether it's a number or a letter, gets translated into a bunch of zeros and ones. Each 0 or 1 is called a bit, and when we group 8 of them, we get what's called a byte. But for now, just focus on this. The more bits we have, the more values we can represent. Let me show you what I mean. So we have this decimal versus binary example. A decimal is a number, for example, 1, 10, 9, 11, 21, and so on. So the digits are represented from 0 to 9. But in binary, we have only bits, which are zeros or ones. So we have 2 bits to represent a binary number, okay? As you can see here, as the number grows, the number of bits we need to represent the number also increases. Okay, so I want to start by showing you guys something really cool, because there is a way to transition from a decimal number to a binary number and vice versa. So let's start with the easier one first. How would I know that a number like 100 is equivalent to 4? The answer is simple, okay? So we start from right to left. So we have this initial 0, and I'm going to just write here the position of the digit. So if we move from right to left, I'm going to say that this is the 0th position. This is the first position. And the last one on the leftmost side, this is the second position, right? So let's just concatenate it like this. It's a simple calculation since binary is in base 2, because there are only 2 digits to represent each bit. We just take this 2, which is the base, power 0, which is the position, and we multiply by the value. So we just multiply by 0. And we add this 2 to the power of 1, which is the position here, and we multiply by the value. So we multiply by 0. And then we add another 2 to the power of 2 this time, because we want to calculate for this position. And the value at the second position is 1. So we just multiply by 1. And this is equivalent to 4. So now that we've seen how to convert a binary number to its corresponding decimal value, we need to understand how to do the reverse, okay? So how would we convert the decimal value 4 to 100 in binary? The answer is simple. We always divide by the base. So we take this 4, we divide it by 2, and this is equal to 2, because we can fit 2 into 4 2 times, right? And the remainder in this case is 0. Now we take the result, which is the 2. We divide by the base again, which is 2, and this is equal to 1. The remainder in this case is 0 again, because we can fit 2 into 2 once. Now we take the result, which is the 1. We divide by 2, and this is equal to 0, but the remainder in this case is 1. Our base case is when we reach the value of 0, so we do not take the 0 and divide again. So how do we get this 100 from our division and the remainders? We just treat it from bottom to top, right? So we start by placing the 1 on the left, concatenating the second remainder from the bottom, which is the 0, and then the top is the 1 at the rightmost. So we get 100 in this case. This is just one last important concept before we dive deep. So let's just get started. What if we want to figure out the different numbers that we can represent using a certain number of bits? We know that in binary we have 0 or 1. Our numbers are only represented using these 2 digits. So if I have only 1 bit, how many numbers can I represent? So I have 2 possibilities in this case, because I have 0 and I have 1. Now let's say I have 2 bits. When I say 2 bits in this case, I mean that we have 2 bits concatenated next to each other. So in this case, we can have 0, 0, we can have 0, 1, we can have 1, 0, and we can have 1, 1. If I have 3 bits, we can represent more numbers. We can have 0, 0, 0, we can have 0, 0, 1, we can have 0, 0, we can have 0, 1, 0, we can have 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0, and 1, 1, 1, right? So we have 8 different possibilities. So if we have n number of bits, we can represent 2 to the power of n different numbers. So I wanted to provide a quick recap. If you have a decimal number that you want to convert to its binary representation, you start by dividing the number by 2, keep on dividing by 2, and each time calculate the remainder, then concatenate the remainders from bottom to top. Now, if you have the binary representation and you want to calculate its corresponding decimal value, write down the positions of the bits from right to left, where the rightmost bit has position 0. Sum the products, where each product is the result of multiplying value, which is the bit itself, by 2 to the power of the position. So far, we've only talked about positive numbers and how they're represented in binary, but computers also need to handle negative numbers. And that's where something called two's complement comes in. It's a more advanced concept that allows us to represent negative values in binary, but we won't get into that here. If you're curious, I've attached a link in the resources section where you can read more about it, but don't worry if it feels confusing. You really don't need to understand two's complement right now. Focus on getting comfortable with binary, the rest will come with time. In the next video, we'll dive into something super practical, Java's primitive data types. See you there.